on what happened the first time, right? So you could have heads and then another heads, or you could have heads and then tails, right? But if the first one was tails, couldn't you also have tails and then heads, and then tails and then tails? Right? Then from there, you can also have heads or tails, heads or tails, heads or tails, or heads or tails. Okay? So we're going to list out all of the possible scenarios. You could have flipped heads 3 times, which is this first one. You could have flipped heads, then tails, then tails. Try to list them all out. See what you get. Okay, so we listed out heads, 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 tails, tails. What's another possible scenario that could happen? Zoe. Heads, heads, tails. Very good. What's another one? Xavier. Heads, tails, heads. What's another one? Stephanie? Tails, tails, heads. What else? Zoe? Tails, heads, tails. What else? Xavier? Tails, tails, tails. And last one, Jaden? Tails, heads, heads. How many possible outcomes are there in total? 8. There's 8, okay? 8 in total, okay? What we're learning today is how do we find that without manually going through each possible scenario, right? So we tossed the coin how many times? 3. Each time, how many possible outcomes were there? 2. So we take 2, we multiply it by 2 outcomes for the second time, and multiply it by 2 outcomes for the third time. What's 2 times 2 times 2? 8. Cool.
Where are you getting all these 2s from?
So the 2s were the number of outcomes, right? You could either have heads or tails, right? So the number of outcomes, if you take that and you multiply it each time, it'll give you the size or the number of possible outcomes you can have overall. Christian, what's up? Oh, is it 11:11? Let's go. Okay. So, number 2, spinning a spinner twice that contains 4 equally likely colors, blue, red, yellow, or green, okay? So, how many possible colors are there? 4, right? And how many times are we spinning the spinner? Twice, right? So we take 4 and we multiply it by 4. Because there's 4 possibilities each time, right? So there's 4 colors, right? There's blue, red, yellow, or green. You guys agree? The second time you spin, how many colors are there? Blue, red, yellow, and green. Do you guys see that? What's 4 times 4? 16. So there's 16 possible outcomes, okay? Let's list them out. You could roll blue on the first one. If you spun blue on the first spin, what could you roll on the second spin? Blue. Let's do blue again. What else could you spin on the second one? Red. What else could you spin on the second one? Yellow. And you could also spin blue and green. Do you guys see that? Then we could spin red first. You could have red and then blue. You could have red and then red. You could have red and then yellow. And you could have red and then green. You could have yellow first. Then with yellow, you could have blue. Then you could have yellow and red. You could have yellow and yellow. Or you could have yellow and green. Then you could spin green on the first spin. And after green, you could have blue. After green, you could have red. Or you could have green and then yellow. Or green and green. Count them all up. There are 16 possibilities here, okay? It says, spinning the spinner mentioned in example 2, followed by tossing a coin. So check this out. Let's draw that spinner really quick. It's divided into 4 spaces. One's blue, one's red, one's yellow, and one's green. Then we're flipping a coin, right? Where it has heads, And what's the other thing? Tails, okay, on the other side. How many possibilities, how many colors are there for the first spinner? There's 4, right? What are the possible outcomes with flipping a coin? 2. How many total outcomes are there? 8, okay? Now let's calculate them, okay? Let's say we spun blue the first time. What else could go with blue? We could spin blue and do what? Flip heads. We could also spin blue and flip what? Tails. What if we spun yellow? If we spun yellow, could we flip heads or tails? So there's going to be 2 possible outcomes if you spin yellow. So you could spin yellow and flip heads, or you could spin yellow and flip tails. You could spin, what other color could we spin? Red with heads or red with tails. You could also spin green with heads and green with tails. How many are there total? There's 8. Okay, is we're talking about sample spaces and probability, okay? So, this is the start of chapter 12. Guys, write this down. Chapter 12, you are also allowed to use a calculator, okay? You will be allowed a calculator, okay? And we're going to be talking about sample spaces, which are all possible outcomes. And probability. Do you guys know what probability means? Giselle? What? The chance or the likelihood of an event happening. You're going to hear that word likelihood a lot. Okay? So, what we calculated was not the probability in the warm-up. We calculated the sample space. Do you see how we listed out all possible outcomes in that warm-up? Okay? That's what we call our sample space. What are all the possibilities of something happening? Okay? So, a probability experiment is an action or trial that has varying results, okay? Okay, an outcome is a possible result of an experiment. So when you roll a die, there are 6 possible outcomes. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. When you flip a coin, there are 2 possible outcomes, a tails or a heads, okay? Now, do you guys remember the spinner from the warm-up? How many outcomes did the spinner have? How many outcomes did the spinner have? One spin. There were 4, right? Because there were 4 possible colors, okay? So the number of outcomes is the number of possible results from an experiment, okay? Please underline possibles because they're not guaranteed to happen, right? If you spin the spinner, are you guaranteed to land on yellow? No, it's possible you could land on blue, red, or green. This one in here, if you were flipping, I'm sorry, not flipping a dice, flipping a coin, what would be an event that could happen? Good. So flipping a coin on heads would be an event, okay? So an event is an outcome or a collection of outcomes. So when you flip a coin, okay, one of the events is that it flips on heads, okay? One of the events is that it flips on tails. Okay, and your sample space is the set of all possible outcomes. So it's every single outcome of, for example, flipping a coin, rolling a dice, okay? So if we flip a coin, what's our sample space? How many possibilities are there? Giselle? 2, okay? If we roll a dice, what's the size of our sample space? 6, okay? If we, what's another thing? Can you guys think of anything else? Ooh, picking from a deck of cards. If you pick a card, How many cards are there total in the deck? 50. Is it 52 or 54?
52.
It's 52. Okay? So our sample size is 52. So it's the list of all possible outcomes. Okay? Okay. Example 1. You flip a coin twice. How many possible outcomes are in the sample space? And list the possible outcomes, okay? So, flipping a coin one time. What's the sample space of flipping one time? One flip. There's 2, right? And then if you flip it again, what's your sample space of that second flip? 2. You multiply those together, what do we get? 4, okay? So in total, we should have 4. But it also wants us to list out all of the possibilities. So when we flip a coin, what are our 2 possibilities, guys? Heads or tails, right? And then when we flip it again, what are our 2 possibilities? Heads or tails. But we could have flipped tails in the beginning, so we got heads or tails. Do you see how there's 4 possible outcomes here? Okay? You could have flipped heads first, heads second, heads first, then tails, tails first, then heads, or tails first, then tails, okay? We list these out like heads, 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 tails, like we did in the warm-up, tails, heads, or tails, tails. Okay, in B, you flip a coin and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes, okay? So we're going to take it one event at a time, okay? You flip a coin. So in our flip, what is the size of our sample space? How many things can happen when we flip a coin? 2 things, right? It can either land on heads or tails, right? So we have a sample space of 2. Then we roll a number cube. Do you guys know a number cube is the same as a dice, right? Because a cube is a dice. How many possible outcomes are there when you roll a number cube? There's 6, right? So we take our sample spaces and we do what with them? Multiply them. So together, what's our total sample space? 12, okay? Now let's list out the possible outcomes, okay? So let's say in our first flip, we flipped heads. What could we roll after we flipped heads? 2. What if we flipped heads? What's another thing that we could have rolled? 3. What else? 4. We could flip heads, roll 5. We could flip heads and roll 6, right? Which one are we missing? Flip heads and roll 1, right? How many are in the sample space of just flipping heads and rolling any number? There's 6 here, right? What if we flip tails, though? We could roll all the same numbers. So you could flip tails, roll 1, flip tails, roll 2, flip tails, roll 3, flip tails, roll 4, flip tails, roll 5, or flip tails and roll 6. So how many total are in here right now, guys? There's 12, okay? We have 6 if we flipped heads, and we have 6 if we flipped tails. Now, the reason I'm listing them all out, if it ever asks you for just the sample space, you can just take the sample spaces, multiply them by each other. But if it asks you to list out the possible outcomes, this is why I'm listing them all out right here, okay? If it doesn't ask you that portion, 12 is an acceptable answer, okay? Just taking the sample spaces and multiplying them by each other, okay? All right. The probability of an event, okay? We already talked a little bit about probability. It's the chance or likelihood that an event will occur, okay? It's always a number between 0 and 1. And those can be written as fractions, decimals, or a percentage. The probability of an event, A, is written as P, and then in parentheses, you put capital A, okay? I would like you to write another one, just so you have reference. Let's say the event was B. The probability of B happening would be P, and then in parentheses we put B. This indicates probability of event B. Okay, so if our probability is 0, that means it is impossible. What's the percentage of it happening? 0%, okay? If our probability is 0.25, it's highly unlikely. What percentage is equivalent to 0.25? 25%, okay? What could be a fraction that also means 25%? 1/4, okay? Remember, probability can be written as a decimal, as a percentage, and as a fraction. Does anyone know how can you change a decimal into a percentage? Yeah, move the decimal point 2 to the right, okay? And from a percentage, you can move it back to a decimal by moving it 2 to the left, okay? All right. What would be if they were equally likely to occur or not to occur? What's our probability? 50-50. Have you guys heard that term before? So 50% is likely to occur, 50% it's not likely to occur. It's an even split. That would be exactly 50%. What's a fraction that goes with 50%? 2/4 or 1/2, okay? It's exactly half. The probability of something likely happening would be closer to 75% or 0.75. What's a fraction that's equivalent to 75%? 3/4. And then if our probability is 1, is it guaranteed that's going to happen? Yes. There's 100% certainty that it'll happen. And any fraction that's 100%, I don't know, 4/4, which simplifies to 1, okay? Any fraction that's certain to happen will simplify to 1. Okay, questions on this slide? Okay. Theoretical probability can be found when all outcomes are equally likely to occur, and your theoretical probability is the number of favorable outcomes, what you're looking to happen, divided by the total number of outcomes, right? This is very similar to like the score that you get on a test, right? So for the score that you get on a test, right? What would you like to happen on a test? You get questions right, correct? So if you picked a right answer, right? Then you divide that answer by what? Or the number of right answers by what? The total number of questions, right? Okay? And that'll give you your score on the test, okay? It's the same thing for probability. So it's the number of favorable outcomes, what you would like to happen, divided by the total number of questions, or the total number of outcomes. So let's go ahead and do 2 examples, okay? One's going to be our coin example, and the other one will be our dice example, okay? So if I asked you, what would be the probability of rolling or of flipping a heads, okay? We would list it like this: the probability of heads occurring, your event, okay? P means probability. What's inside your parentheses is your event. So what is the probability of heads? Xavier? It's 50%, but let's list it as the number of favorable outcomes, which is 1, right? There's 1 chance that we roll heads out of how many possible outcomes are there? 2. And 1/2 simplifies to 50%. Okay? Now, let's do the probability of rolling a 2. Okay? Now, of all the number of favorable outcomes, right? If our favorable outcome is rolling a 2, how many outcomes is that? Yeah, Jaden? It's once, right? There's one chance that we roll a 2. Out of how many total outcomes are there? 6. So our probability is 1 over 6. Okay? And then if you plug that into your calculators, 1 divided by 6, 0.17. Move the decimal 2 places to the right to give us a percentage. What percentage is this? 17%. Okay? Yes? Yes. So to change from a decimal to a percentage, you can think about it as moving the decimal or just multiplying by 100. Okay? They're all equivalent as long as you add that percentage symbol. Okay, let's do the die again. Okay, so we're still on the die, but let's do what's the probability of rolling an even number? Okay, now hold on. So, rolling an even number, how many possible outcomes would we have, the number of favorable outcomes for rolling an even number? Xavier? 3. Why? Very good. You could roll a 2, a 4, or a 6. So there's 3 possible outcomes that are favorable out of how many total? 6. What is 3 over 6 simplify to? 1/2 or 50%. So there's a 50% probability that you roll an even number. Yes? Okay. Example 2, you toss a coin and roll a number cube. That's also a dice, okay? What is the probability that the coin shows heads and the number cube shows 5? What is the probability that the coin shows heads and the number cube shows 5? Okay? So we're looking for heads and 5, right? The probability of heads and 5. All right. What is this outcome? Is it likely to happen once? Are there 2 possible outcomes? How many times is this favorable? Xavier? Once. Okay? It's a very specific case of heads and the number 5 out of our total sample space. What's the total sample space for tossing a coin and rolling a number cube? 12. Okay? Now, remember, tossing a coin had how many possibilities? 2. And rolling a number cube? 6. That gives me my total sample space of 12. 1 over 12, plug it into your calculator. We're going to get 0.083, which converts to what as a percentage? 8.3%. What is the probability that a student chooses a t-shirt with a gold emblem? Okay, so what this chart is saying is it's saying, okay, for gold emblems, there's a total of 16, right? There's 10 on green t-shirts and there's 6 on red t-shirts. For silver emblems, there's a total of 14. There's 8 silver emblems on green t-shirts and 6 silver emblems on red t-shirts, okay? Are there any questions on how to read this chart? Yeah, Jaden? No, never mind. Okay. What is the probability that a student chooses a t-shirt with a gold emblem? Guys, I would like you to write this one out the way that I'm going to. So we're looking for the probability of a gold emblem, correct? Make sure you have a P and then a parentheses. So we need to know the number of gold emblems over the total t-shirts. Okay, what would be the number of gold emblems? Christian? Very good. How'd you get 16?
We take all the numbers from the gold emblem column.
Very good. So we're going to do 10 plus 6, which gives us 16 in the numerator. Okay? So we have 16 over, what's the total number of t-shirts? Xavier?
30.
It's 30. Okay? So we have 16 over 30. And this simplifies, guys. What does it simplify to? 8 over 15. Does it simplify any further? No. We can leave it like this, but for our sake, guys, I would like us to change this into a percentage. So do 8 divided by 15. You should get like 0.53. Repeating, which we're going to round to 0.53, which is what percentage? 53%. Okay, remember you move the decimal place over 2 times.
Are we always rounding it to a whole number?
It'll tell you, okay? If it doesn't, I don't really mind if you round it to a whole percentage or the tens place, okay? I'm not picky about what we round to unless the question specifies, all right? Questions? All right. The probability of the complement of an event, okay? So the complement, underline that, is just if the event didn't happen. Okay? So the probability of the complement of event A is probability of A bar equals 1 minus the probability of A, okay? Please write in, this is written as A bar. Or it's pronounced A bar, okay? That's how we say it. And it's the likelihood of the complement. So what is the likelihood that A does not happen, okay? So what if the probability of A happening is 0.45, the probability of A bar would be 1 minus the probability of A. In this case, it's 1 minus 0.45, which is 0.55. Okay? You do 1 minus the probability of the event happening to find the probability of the complement. So let's do one extra example. Let's say we did the probability of rolling a 4 or a 5 on it with a dice or die, okay? And we want to take the complement of it, okay? So we would set this up as 1 minus the probability of rolling a 4 or a 5. Okay, what is the probability of rolling a 4 or a 5? Xavier?
2 over 6.
It's 2 over 6. So we're going to do 1 minus 2 over 6, which in this case would be 1 minus 1 over 3. 1 we have to change to have a common denominator. So it would be 3 over 3 minus 1 over 3, which is 2/3. So the probability of not rolling a 4 or a 5 is 2/3. You have a 2/3 chance or 4/6, okay? But we should always simplify. Because there are 4 numbers on a dice that are not 4 or 5. Yeah. When told. The 3 over 3, yes, okay? This 3 over 3 is 1, right? Because 3 divided by 3 just gives us 1. We need to find a common denominator, though. Yeah. Yes. All right. Yes. Okay. This is how geometry comes into play, Christian. Okay? So geometric probability can be found by calculating a ratio of 2 lengths, areas, or volumes, okay? Example 4. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points, okay? So we have to figure out, okay, what is the area of the 10 points space? What kind of shape is the 10 points? It's a circle, okay? So if we're looking at the 10-point area, we need to find the area of this circle, okay? What is the area of this circle? Xavier? Pi r squared. Very good. And our radius, this is saying that 3 is each of these lengths. So this is 3, this is 3, this is 3, okay? So it's going to be area equals pi times 3 squared. So area equals 9 pi. Now, what is the sample space? How could we find the sample space? Like, what are all possible outcomes? Like, where could the dart land? Where could the dart land? It could land 0, it could get 2, or it could get 5, right? Or 10. So it could land anywhere inside the square board, right? So our sample space, okay, total outcomes would be the area of the whole board. Okay? So how do we find the area of this whole board? Christian? So what shape is the board?
Oh, you mean the square?
The entire thing, yeah. It's actually a square, you're right. Yep.
Double the radius.
Double the radius.
The radius is 9, so it's going to be 18. And then, so that's one of the sides.
Yep.
And then the other side is also 9, so it's a square. So, yeah.
Very good. So our area is going to be 18 times 18 because this is a square board. Each of the sides is 9. So 18 times 18, so the area of the whole thing is 324. Inches squared. Where did I get the radius? Okay, so each of those lengths is 3, right? So we add all 3 of them together. You get 3 plus 3 plus 3 gives you 9. Okay, so the radius is 9. The diameter would be 18. And that's the length of each of the sides. Other questions? Yeah. Carlos? Scroll up just a little bit. So when we're finding the probability of hitting the 10, right? It will be the area of the 10 over the total area. We calculated the area of hitting a 10. What was it? It was that pink circle, right? Which calculated to what? 9 pi, yeah. So if we do 9 times pi, it's about 28.3, okay? And then we're dividing it by the total area, which is 324. So plug in 9 pi divided by 324. And you should get like 0.087. Which converts to 8.7%. So the probability that we hit a 10, right, which is the best score, aiming for the center of the square, would be 8.7%. But we have to compare that to the likelihood of hitting a 0. So the probability of hitting a 0. Okay? Now 0 is that blue space on the edge of the board. Do you guys see that? It would be hitting like somewhere over here in the blue area. Okay? So in order to find out the probability of hitting a 0, you have to find the area of the 0 over the total area. Now, the total area, we're still going to use 324, but how could we find the area of hitting a 0? Xavier?
Subtract the area of the circle.
Very good. If we subtract the area of this largest circle from the area of the whole board, that'll give us the region in blue. Do you guys see that? If I took away this region in black, okay? So how we're going to set it up is it's going to be the area, total area, minus area of the 2 over the total area. We already know total area, it was 324. We subtract the area of 2 would be pi. The radius of the yellow circle is what? It's not 3. That was the pink one.
9.
It's 9. Okay, we have to add 3, 3, and 3. So we get 9, we square it, over the total area, which was 324. So we do 324 minus 81 pi, and then we divide that by 324. I got 0.215, which is 21.5%. So which one, guys, is more likely to happen?
0.
Hitting a 0, okay? So the probability of hitting a 0 is more likely. Yes, Christian.
It says in instructions that
Experimental probability. This is based on repeated trials of an experiment. It's the number of trials. The number of trials is the number of times the experiment is performed. Success is each trial in which the favorable outcome occurs, okay? So it's very similar to theoretical, okay? But theoretical, you're not actually performing the experiment, okay? Experimental probability is the actual number of successes divided by the number of trials. Theoretical is if everything was equally likely to happen, okay? So experimental, the experiment is already going to happen. You guys are calculating, okay, what were our results based on that experiment? So your experimental and your theoretical, guys, they don't have to match, okay? And there will be cases where they do match and cases where they don't match. Last example. Each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability, okay? So what we're going to calculate first is theoretical, okay? So let's write down theoretical. This is if it was equally likely to hit anywhere on the board, okay? So what is the probability of hitting the blue color? Xavier? It's 1 out of 4, right? Because they're equally spaced colors. What is the probability of hitting a yellow? 1/4. It's 1 out of 4 colors. What is the probability of hitting a green? 1/4. And the probability of red? Okay, so these are all our theoretical probabilities, okay? That's if everything was perfect, right? In a perfect world, we would have a fourth, a fourth, a fourth, and a fourth. Now, it is not guaranteed that our results are divided into 4s, right? There's a chance, there's random chance, right? So when we perform the experiment, we're checking, okay, which of these results match the theoretical, okay? So right down below the chart, write down this is our experimental. Okay? The experimental is coming from the results of our experiment. Okay? So, our red spinner, experimental probability for the red spinner was the number of successes. How many times did red happen? 5. Out of how many total spins? 20. Okay? The probability of green from experimental, how many times did green happen? 9. Out of how many total spins? 20. The probability of blue, 3 over 20. And the probability of yellow, 3 over 20. Okay? Which one of these experimental probabilities matches the theoretical for that color? Red. Very good. Okay? Because red is 5 over 20, right? Oops. 5 over 20 simplifies to 1 over 4. And 1/4 is the same as the red one. So our answer is the red. Okay? This is where we're stopping. Turn these in.